Have you ever just stared blankly at a whiteboard during a technical interview? Or maybe you felt completely overwhelmed by the sheer volume of coding concepts you're told you need to master for those top-tier tech jobs? Well, listen, if that sounds familiar, you are exactly where you need to be. In today's Explainer, we are unpacking the ultimate quest. We're taking a deep dive into the 75-day data structures and algorithms hard challenge. We're going to walk through the exact roadmap, look at the escalating difficulty of the problems, and really dig into the mindset you need to transform from a tentative coder into a highly sought-after engineering candidate. Okay, let's dive into this. Think of this as your strategic map for the next 2.5 months. We'll start with the ultimate DSA challenge, move right into mastering foundation basics, and then navigating linked lists. From there, we are conquering trees and graphs, tackling advanced problem solving, and finally, reaching the finish line, achieving tech interview success.
All right, Section 1, the ultimate DSA challenge, defining the goal.
Now, before we write a single line of code, we absolutely have to understand the core motivation behind this rigorous journey. We aren't just solving puzzles for fun here, right? This is a highly structured path to a life-changing career milestone. Consider this massive number, 24. That stands for the 24 lakhs per annum average package waiting for professionals who truly conquer this material. The data from our source shows that an incredible 2 out of 3 alumni who commit to this level of preparation actually land jobs at top product-based companies, and a lot of times they're securing more than one offer per person. That is the literal pot of gold at the end of this 75-day rainbow.
But you might be wondering, how do you actually get there? There's a really interesting disclaimer right in the source documents that says, everyone learns uniquely. What matters is developing the problem-solving ability to solve new problems. This right here is our foundational mindset anchor. Look, this challenge is not about memorizing 100 different LeetCode answers. If you just memorize code, I guarantee you will fail the interview the second they change a single variable. We are building a problem-solving philosophy from the ground up.
Moving on to Section 2, Mastering Foundation Basics, the warm-up. So, in the early days of the challenge, you can neatly categorize the initial chaos. This is basically the first stage of our hero's journey, where we start building essential momentum. For a bit, you are going to live and breathe arrays and strings. On one side, we've got classic array manipulation tasks, things like shuffle the array and finding good pairs. On the other side, string manipulation pushes your logic just slightly further with longest palindromic substring and valid palindrome. These are the fundamental building blocks. And trust me, if you don't have these completely locked down, the later weeks will absolutely crush you.
And this brilliantly illustrates the sheer intensity of the ramp-up in this 75-day challenge. Think about this contrast. On day 1, you're asked to shuffle the array. It's straightforward, it gets your fingers moving, it builds up a little confidence. But fast forward to just day 16, and suddenly you are tasked with writing a program to solve a Sudoku puzzle by filling the empty cells. I mean, that is a massive jump into backtracking and complex grid validation in just over 2 weeks. The escalation is real, and it demands your daily focus.
Section 3. Navigating linked lists, connecting the dots.
Okay, this is the phase of the syllabus where memory management and pointers become the real test of a developer's grit. If you studied computer science, you know that linked lists are where things start to get tangled. When it comes to the specific problem types, you start off gently by simply reversing a singly linked list, then merging 2 sorted lists. But pay attention to that third point, reverse nodes in K-group. The source highlights this as a notorious challenge. You actually have to reverse the nodes of a list K at a time, without altering the values inside the nodes. You're only changing the actual node pointers themselves. This one is a classic, heavy-hitting interview favorite.
You know, when you are manipulating linked list nodes without losing your crucial head pointer, your logic has to be incredibly precise. Literally, one misplaced bracket or one pointer reassigned in the wrong order and boom, your entire application crashes with a memory leak or a null reference. Absolute precision in logic and syntax is entirely non-negotiable here.
Section 4, Conquering Trees and Graphs, the Branching Paths. All right, we have officially entered the critical midpoint of the challenge. We are leaving linear data structures behind, and we're dealing with complex routing. The syllabus outlines a very clear progression for us. Step 1 is mastering binary tree traversals, things like preorder and level order. Once you actually understand how to move through branches, Step 2 expands that into grid logic, tackling famous problems like the number of islands, where you have to find clusters of land connected horizontally or vertically. And finally, Step 3 throws you into pure graph paths with problems like network delay time, where you are calculating the minimum time for a signal to travel through a complex web of directed edges and nodes.
Section 5. Advanced Problem Solving, the Final Bosses. Okay, take a deep breath. This is the stuff that separates a junior developer from a top-tier engineer. Here is where we get into dynamic programming. These are the heavyweight challenges you're going to face in the final stretch of the 75 days. Finding the maximum subarray. Calculating unique paths for a robot moving through an n-by-n grid. Calculating the edit distance, which is the minimum operations required to convert one word to another using inserts, deletes, and replaces. These algorithms require you to break a massive problem down into overlapping subproblems and optimize your solutions so your code doesn't take, 3 years to run.
So the crucial point is perfectly captured in the coin change problem. Picture this. You are given an infinite number of coins of different denominations and a total amount. You need to return the fewest number of coins to make up that amount. It sounds like simple math you'd do at a cash register, right? But programmatically, brute forcing this will entirely destroy your system's memory. Dynamic programming is exactly what allows you to manage these theoretically infinite resources efficiently, saving your previous calculations so you can reach the optimal answer almost instantly.
Section 6. Achieving Tech Interview Success, the Ultimate Reward.
So why put yourself through 75 days of arrays, tangled pointers, and mind-bending dynamic programming? Well, because of the metrics. Let's recap what we learned from the source material right at the beginning. You aren't just learning to code, you are unlocking serious career mobility. With 66% of alumni placed, earning an average package of 24 LPA, and typically securing more than one offer, conquering this grueling syllabus proves to employers that you have the raw problem-solving horsepower they desperately need.
And to reach these heights, expert mentorship, like an ex-Microsoft masterclass, is heavily woven right into the journey. Top-tier placements at companies like Microsoft are not just pipe dreams. They are the tangible, documented end results of surviving this very specific 75-day process. You build the fundamental skills, you master the advanced optimizations, and then you learn directly from the people who have already conquered the exact interview rooms you want to enter.
We've looked at the syllabus, we've seen the brutal escalation from simple arrays all the way to dynamic programming, and we know the massive career rewards waiting on the other side. So I leave you with one simple question. Are you ready for day one? Grab your keyboard, set up your environment, and let's start coding.